Again, we've seen permutations already in the previous stuff. This is the thing I highlighted before, and we wrote in our notes, that a permutation order is important. For right now, we're only dealing with permutations, but later when we have combinations, and then when the questions get mixed together, you have to read a question and you have to decide, is the order important or not, to decide whether you're going to use permutation strategies to solve it or combination strategies. So if you have ABC, okay, anytime you're solving a permutation question, you can find out how many answers there's going to be with spaces. How many decisions would you have to make if you're rearranging 3 letters? 3 decisions. There's how many choices for our first letter? 3, then 2, then 1, or 3 factorial, which is equal to 6. So now if we're going to list them, sometimes. It is kind of time consuming. At least it wasn't the whole alphabet. Oh, that would be nasty. 26 factorial, type that into your calculator and you can see how many you would have to write out. Yeah. So, the symbol for number of permutations, and this is on our formula sheet, n factorial over n minus r. Some things that you can do mental math-wise. If you have NPN, there's the formula, but this is like 5p5. Remember that this stood for how many spaces we have, and this was our choices that we begin with. So 5 spaces, 5 choices to begin with, 5, 4, 3, 2, 1, will make sense that that is 5 factorial. So again, if you think of the NPN or the 5p5, second one is your spaces, first one is the amount of choices that you start with, then you can do these a little bit mental math easier and quicker, rather than thinking of the formula. Okay? So for something like 8p2, what's that in your head? 8 times 7, 56. Right? There would be 2 spaces, starting with 8, then 7. According to the formula says 8 factorial over 8 minus 2 factorial, which is 8 factorial over 6 factorial. And if you expanded the top until you got to 6 factorial and canceled out, you'd be left with 8 times 7. But thinking of the spaces and how many choices you begin with is a little bit quicker as far as mental math goes. Because sometimes they'll have ones like that on a non-calculator, on a multiple choice kind of question for you to figure out. So the wind ensemble has 10 pieces of music that they're really, really good at, performance ready. Is that true, or is it more than that? Yeah. 2 pieces of music that are performance ready, not 10. But let's imagine that we have 10 pieces that are ready, and they want to make a program, and the order matters, because it's kind of awkward if you play O Canada, the 3rd song in, right? So the order matters. How many ways can they do that? Well, you have 4 decisions to be made, 10 choices for your first, 9, then 8, then 7. Of course, you could solve this with permutations on your calculator as well, but for permutations, most of the time, if we can use spaces, it will be the easiest. Now, number of permutations of the word math. Well, there's just 4 letters. You could do 4 spaces and then go 4, 3, 2, 1. Or you might say, well, with words and rearranging the letters, that's just as easy to just go 4 factorial right from the beginning. So these first couple of examples have been relatively straightforward. Sometimes where things get more complicated or with an example like this. So 5 people come in for math help and there's 12 desks available. okay? How many ways can the students be seated? And the reason that this one is harder mentally for a lot of times is because you're so used to sitting in desks that you want to put your spaces as 12 of them, because there's 12 there's 12 places you can sit, and you want to put things into desks. And we put numbers into spaces, so it sort of feels that way. But then when you start with your numbers as 5, 4, 3, 2, 1, you run out of numbers before you run out of spaces, and you have a problem. So again, we go back to the wording that we've used all the way along. How many decisions need to be made in this situation? There's only 5 decisions that need to be made. Person 1 walks in. They have a decision. Where am I going to sit? How many choices do they have? 12. Then person 2 has 11. Person 3, 10, 9, 8. So for this class, we could figure out, I've got 1, 2, 3, 4, 5, 6, 7 times by 5, 35, 36, 37, 38 desks, 32 people in here. We could figure out how many seating plans we could make for this class. Now, 32 people would mean 32 decisions. At this point, the spaces gets long and tedious. So for our seating plans, we have 38 choices, 32 students. This is where the formula is nicer than the spaces, just because you can write it more succinctly. You can go to your calculator to figure it out. Math over to probability. You have to type in the 38 first. Nice. 7.26 times 10 to the 41. Did I, NPR. Oh, I put C. That is a mistake. Thank you. Those are for combinations. We'll do that next. 7.26 times 10 to the 41. You know what 10 to the 41 means? 41 zeros. So that's a lot of seating plans. So there's got to be one that works best, the most optimal seating plan where the most people are happy. And we just have to look through all of those to figure out which one it is. So that's how many seating plans we have for this classroom.